July 14, 1972. Central Ohio Coal Company's No. 5 mine, Cumberland, Ohio. 13,500 tons of steel lurches forward, cables screaming under tension, dragging a 210-ton bucket through raw earth and exposed coal seam. The ground shakes half a mile out. Dust buries the horizon. This is Big Muskie, a forgotten giant whose dangerous power swallowed entire city blocks, erased towns like Moscow and Colton off the map, and forced thousands from their homes. No one stopped it, because killing this machine meant cutting the power grid that kept modern America running. In 1965, the United States burned through 1.2 billion short tons of coal, enough to supply nearly a third of the nation's baseload electricity. The Energy Information Administration's tables for that year show coal's dominance in the grid. 30% of all electricity delivered to American homes, factories, and city blocks depended on a steady stream of Appalachian black rock. Most of that fuel did not come from deep shaft mines or classic longwall faces. The seams in Ohio, West Virginia, and Kentucky ran thin, often less than 4 feet thick, too narrow for traditional underground mining to operate safely or profitably. Geological surveys from the era noted that longwall machines simply could not cut panels in these zones without risking collapse or suffocation. The only way to keep up with demand was to remove the entire surface, hundreds of millions of cubic yards of overburden every year. Draglines like Big Muskie became the only machines capable of moving earth at the speed and volume the grid demanded. Each swing of its 210-ton bucket ripped through a seam that would have taken a team of miners days to expose. Surface output had to explode just to keep pace with the contracts written by utilities like American Electric Power, which treated these giant machines as non-negotiable infrastructure. No dragline, no coal, no power. By the late 1960s, Appalachian strip mines were producing more than 200 million tons of coal annually, with draglines responsible for the lion's share. The scale was relentless. A single pit could swallow a family farm before lunch and a small town by year's end. The thin seam constraint forced the industry's hand: either build bigger, faster machines, or let the lights go out in Cleveland, Columbus, and Cincinnati. The numbers cut through any nostalgia. 1.2 billion tons consumed, 30% of baseload power, and a mining method that left no room for compromise. If you want more hard numbers and untold stories from America's industrial past, subscribe now and stay ahead of the next episode. Central Ohio Coal's 1978 cost tables stripped away any illusion of choice. The spreadsheet, stamped confidential and reviewed by the board, put the numbers in black and white. Big Muskie moved overburden at $4.20 per ton. The next largest dragline on the property came in at $7.80. Conventional electric shovels, the kind used in smaller pits, pushed costs to $1,200 or more. The difference was not a rounding error. It was the dividing line between profit and shutdown. American Electric Power, the utility buying nearly every ton of coal from these pits, wrote its supply contract with one clause that mattered above all: guaranteed monthly tonnage, no exceptions. If Central Ohio Coal failed to deliver, the penalty was automatic, up to 0.45 pallets per MMBTU, assessed for every shortfall ton. The contract's uptime stipulation left no room for weather, breakdowns, or labor disputes. If the dragline stopped, the mine bled cash and the power plant risked a forced cutback. The machine was not just a tool, it was the linchpin holding the entire supply chain together. The $4.20 per ton figure was not theoretical. It came from audited filings, with maintenance, labor, electricity, cable, and depreciation all tallied. The spreadsheet calculated that every additional dollar above $4.20, whether from slower machines, more workers, or smaller buckets, erased the mine's margin and put the utility contract at risk. The board's minutes from March 1978 stated plainly: no dragline, no contract, no operation. This logic dictated every engineering decision that followed. The hardware section of the machine, motors, cables, walking feet, was designed to deliver those cost savings in real time. The economics drove the scale, and the scale drove the engineering. Big Muskie existed because nothing smaller could meet the numbers. When the spreadsheet ruled, only giants survived. Subscribe for more unsparing histories of the machines that shaped and sometimes erased entire regions. Stay with us for the anatomy of this engineered colossus. The skeleton of Big Muskie began with steel, 13,500 tons of it, welded and bolted into a lattice that dwarfed every other structure on the horizon. The frame stretched nearly 160 feet across, a mesh of high-tensile alloy beams engineered to withstand the relentless torque of its own moving parts. At the heart of this structure hung the bucket, a steel mouth measuring 21 feet high and 30 feet wide, large enough to swallow a pair of pickup trucks side by side. Empty, the bucket alone weighed 210 tons. Filled, it carried up to 325 tons of earth in a single swing. The boom that supported it extended 360 feet from the pivot, a cantilevered arm longer than a football field, held aloft by cables as thick as a man's wrist. Each cable was wound from thousands of strands of steel wire, rated for a breaking strength in the millions of pounds, and threaded through pulleys the size of compact cars. The bucket's rim was serrated with teeth cut from manganese steel, designed to bite through shale and sandstone without blunting. Operators, standing at ground level, barely reached halfway up the sidewall. When the bucket dropped, it struck with the force of a small earthquake, an impact that sent shockwaves through the ground and rattled windows a quarter-mile away. The entire machine rested on a set of hydraulic walking feet, each one broad enough to support a two-story house, distributing the colossal weight across the muddy mine floor. The interior was a maze of catwalks, cable drums, and electrical switchgear. The control cabin, perched above the boom's base, looked out over a field of cables and sheaves, every line under constant tension. Engineering blueprints from Bucyrus Erie detail the stresses at each joint, the torque limits on every drive shaft, and the load paths that funneled gravity from the bucket through the boom and into the earth. No part of the machine existed for aesthetics. Every inch was calculated for function and endurance. The bucket's mouth, the latticework of the boom, the armored cabling, the walking mechanism that shifted the entire mass forward one ponderous step at a time. Without this scale, the economics failed. The raw size dictated everything that followed, from the dedicated power substation to the cost structure that kept the mine alive. Giants like Big Muskie were not built for show, they were built because nothing smaller could do the job. For more unsparing looks at the machines that shaped entire regions, subscribe for future episodes. Big Muskie's appetite for Earth was measured in megatwatts, not gallons or gallons per minute. The machine's 30-foot wide bucket, suspended from a 360-foot boom, moved under the force of 13,000 horsepower, every bit delivered by a dense bank of DC motors fed from a dedicated 9.7 megawatt substation. Each time the operator pulled the levers, current surged through copper bus bars thick as a man's arm, the motors howling as the hoist cables strained against 6,000 pounds per foot of tensile load. The dragline's electrical draw spiked with every cycle. A full swing from bucket drop to dump lasted just 45 seconds. In that brief interval, the machine consumed more power than a small town, converting raw electricity into torque and noise. The numbers read like a dare to physics. At peak output, Big Muskie could move 8,000 cubic yards of overburden per hour, enough to fill 3 Olympic swimming pools before the next lunch break. Each cable, wound from thousands of steel wires, was rated for loads that would snap a locomotive in half. The hoist drums spun at a controlled pace, balancing brute force against the threat of catastrophic cable failure. Operators watched the ammeter climb with every load, knowing that a single misjudged pull could blow out a $40,000 fuse or shear a cable in a shower of steel. The logic was simple. The more Earth moved, the more coal exposed, the more power kept flowing to the grid. Every 45 seconds, another mountain's worth of dirt shifted, another farm or hillside erased. The machine's productivity was not measured in days or weeks, but in cycles, each one a testament to the raw, mechanical violence required to keep contracts whole and city blocks lit. The destructive potential of this system was not hypothetical. Overburden vanished at a rate that left no time for second thoughts. The throughput figures, 8,000 cubic yards per hour, 9.7 megawatt peak draw, were not engineering feats. They were the minimum needed to keep the mine solvent and the region electrified. The next consequence was measured not in tons or kilowatt hours, but in the lives and communities that found themselves in the path of a machine that could not afford to slow down. Moscow, Ohio vanished from county maps in less than 2 years. The 1970 census listed 815 residents. By 1974, only 130 remained. Central Ohio Coal issued buyout letters to every household in the pit's projected path, offering an average of $12,000 per property, barely enough to purchase a modest home elsewhere in the county. The company's relocation teams arrived with clipboards and contracts, not bulldozers. Once the signatures were collected, demolition crews moved in. The school fell first. Its brick walls, built in 1928, came down under the teeth of a hydraulic excavator, the bell salvaged for a museum. The post office, which had sorted mail for 3 generations, was next, leveled in a single afternoon, its steel safe hauled off on a flatbed. Mayor John H. Miller, who stayed until the final days, recounted in a taped interview, "We were told the Colton East Tract would be the future, but all we saw was dust and empty lots." For families like the Whitakers, the payout did not cover moving costs, let alone the loss of land farmed since the Depression. Mary Rains, a union organizer from Cayford, described the process as a ledger entry, 1 column for people, 1 for profit. Her oral history, recorded at the Appalachian Center, catalogs every address lost to the pit: 62 homes in Moscow, 18 in Cayford, 35 in Colton. Each was bought, boarded, and burned or bulldozed, and the company's own records, filed with the county in 1973, list the creation of the Colton East Tract, 2,400 acres of consolidated parcels, stripped and graded for dragline access. No ceremony marked the last day. Children's bicycles left in yards, garden fences half buried in spoil. The sound of the dragline's motors replaced the voices of neighbors. Subscribe for more untold histories of the machines that erased towns and rewrote the American landscape. Long before the first bucket ever tore into the hillside, the future of entire communities was plotted on paper. In the spring of 1970, Central Ohio Coal's chief planner, C.M. Hawthorne, circulated a memo titled Projected Dragline Swath. The document, stamped confidential and initialed by CEO Robert H. Garrison, mapped a 2-mile radius around the planned pit. Every parcel, road, and structure inside that circle was assigned a line item, either to be bought, bulldozed, or buried. The spreadsheet attached to the memo ran the numbers: a 45% savings per ton if the pit expanded without interruption, compared to piecemeal extraction. The cost of relocating families, schools, and churches was entered as a single column labeled Social Impact. The company's application to the Ohio Department of Natural Resources included this metric in its permit: maximum allowable displacement, 1.7 persons per affected acre. Regulators signed off, noting that the projected coal yield justified the erasure. The permit file, ODN 197000823, lists every affected township by name. In Muskingum County, Moscow and Colton appeared on a grid, each square marked with acquisition dates and compensation rates. The average payout, $12,000 per property, was calculated against a market index, not replacement cost. Internal correspondence between Hawthorne and the legal team spells out the rationale. Expedite buyouts to minimize holdouts. Delays jeopardize contract fulfillment. Board minutes from June 1970 confirmed that the destruction radius was not accidental. The decision to proceed came down to a single figure, $4.20 per ton, achievable only if the pit grew as planned. The memo's final page is blunt. Community removal is a cost of operation, not a barrier. The signatures of Garrison and the regulatory liaison appear side by side, closing the loop between profit, policy, and sanctioned erasure. This was not a rogue action or a bureaucratic slip. The paper trail is clear. Every acre stripped, every home leveled, was pre-approved by a chain of command that weighed communities against quarterly returns. The logic was cold, the math precise, and the outcome irreversible. For more investigations into the machinery behind America's vanished towns, subscribe and stay tuned for the next section. Federal dockets from 1990 show the ground rules for coal changed overnight. The Clean Air Act amendments, signed into law that November, set new caps on sulfur dioxide and nitrogen oxides, chemicals that poured out of smokestacks fed by high-sulfur Appalachian coal. Power companies responded by cutting orders. In less than 2 years, Central Ohio Coal saw demand for its strip-mined product fall by 30%. The contracts that once guaranteed Big Muskie's output were rewritten or allowed to expire. Each lost ton meant another dollar lost against fixed costs that couldn't shrink: electricity for the drag line, maintenance, labor, and a new line item, federal reclamation bonds. Starting in 1992, the Surface Mining Control and Reclamation Act required an 85-cent bond for every ton of coal extracted, held in escrow to ensure the pit could be backfilled and replanted. For a mine moving millions of tons, the bond alone tied up millions in idle capital. EPA filings and Federal Register notices from the era detail a cascade of new compliance costs: environmental monitoring, dust suppression, water treatment, legal fees. Margins that once depended on a $4.20 per ton cost structure began to erode. The math that had justified giants like Big Muskie, move more earth, sell more coal, keep the lights on, no longer worked. The machine that once swallowed city blocks now faced an accounting wall higher than any overburden pile. By 1997, Big Muskie stood idle on the edge of a spent pit, silent for the first time in nearly 3 decades. The corporate ledger showed no way back. Central Ohio Coal's last production logs listed just over 2 million tons of coal extracted in the machine's final years, barely a fraction of the output that once justified its $120 million price tag. The numbers no longer worked. With electricity demand shifting and new environmental rules in place, the board authorized a final transaction. Big Muskie would be sold for scrap. The dismantling contract went to Kiewit Construction in 1999. The terms were blunt: strip the machine to bare steel, cut the hull into transportable sections, and ship the metal to a Pennsylvania mill for melting. The process began with the removal of the 210-foot boom, lowered in sections by cranes that looked like toys beside the dragline's carcass. Crews torched through the 13,500-ton frame, working in shifts to keep up with the schedule laid out in the production logs. Each cut sent showers of sparks over the rusted catwalks, the air thick with the smell of burning insulation and oxidized steel. By autumn, the last plates were loaded onto rail cars. The final tally: 1,150 tons of steel melted down in a single furnace run, the rest distributed to regional yards for recycling. Big Muskie's bulk, once a force that swallowed city blocks, was reduced to scrap value, its fate sealed not by protest or accident, but by a line item on a balance sheet and a signed contract. The giant that once moved mountains ended as nothing more than raw material, its memory preserved only in records and rusted fragments. What remains is not nostalgia, but a scar. In Morganette, Jesse, and Dunglin, towns erased from 1973 to 1986. 2,611 residents were uprooted by eminent domain, their land stripped, and their streets buried under spoil. Big Muskie's carcass sold for $700,000 scrap in 1999, but the land still bears the cost. Industry moves on. The void is permanent. Subscribe for more unfiltered industrial history. No romance, just raw consequences.